These are the model examination questions of chapter 1, graphs, terminology and basic concepts. Question 1, it is asking that show that the maximum number of edges in a simple graph with n vertices is n of n minus 1 upon 2. Since the graph is simple, it has no self loops and parallel edges. Since it has n vertices, each vertex is adjacent to almost n minus 1 vertices. That is, the degree of each vertex is at most n minus 1. Then, sum of degree of all vertices is n of n minus 1. We know that sum of degree of all vertex equals 2 multiplies number of edges. This formula is used to find the degree of all vertex. Therefore, n of n minus 1 equals 2 multiplies number of edges. Therefore, number of edges equals n of n minus 1 upon 2. Move to next question. If a graph has 16 edges with all its vertices of degree 2, then how many vertices does this graph have? Given that all vertices of the same degree, that is degree 2, so it is a regular graph. Here the formula is used to find the sum of the degrees. Therefore, sum of the degrees is equals 2 multiplies of number of edges as well as number of vertices multiplies degree. Therefore, this could be the equation 1, that equals the twice the number of edges. Given that number of edges are 16, so I am naming it as equation 1. As we know that sum of degree equals number of vertices multiplies degree, so I am naming it as equation 2. After equating equation 1 and 2, we get number of vertices equals 16, that is n equals 16. Move to question number 3. How many vertices does a graph contain if it has 21 edges, 3 vertices each of degree 4 and other vertices each of degree 3? We know that the sum of degree across all nodes is equal to twice the number of edges. Let there be n vertices in this graph. According to the given data, 3 vertices each of degree 4 and other vertices each of degree 3. After solving this problem, we get number of vertices capital N is equals 13. Let us discuss question number 5. If G is a simple graph with 15 edges and complement G has 13 edges, how many vertices does the graph G have to? Say G and complement G have n vertices. Well then, since G has 15 edges and its complement has 13 edges, the complete graph on n vertices has 28 edges. We know that a complete graph on n vertices has n of n minus 1 upon 2 edges. Therefore, 28 equals n of n minus 1 upon 2. Calculate the value of n. We get number of vertices as 8. Let us discuss question number 6. In a graph G of V comma E, let capital M and small m denote respectively the maximum and minimum of the degrees of the vertices in G. Then show that small m less than or equals 2e upon v less than or equals capital M. Let V be the set of vertices. We have MV less than or equal summation U belongs to V degree of U less than or equal MV. Therefore, MV less than or equal to E less than or equal MV. Thus, M less than or equal 2E upon less than or equal capital M. Let us move to the question number 7. Find the maximum possible number of vertices in a graph with 35 edges and all vertices of degree at least 3. We know the formula sum of degree of all vertices equals twice the number of edges. The number of edges is one half the sum of the degrees. Thus, the number n of vertices can be no larger than 70 upon 3. Since n is an integer, it can be no larger than 23. If we create a graph with 22 vertices of degree 3 and one vertex of degree 4, the number of edges is 70 upon 2, that is 35.